In this video, I'm going to show you how to solve a vertical equation, and first let me remind you the steps of the process. So in step 1, we would isolate the vertical term. So we would want our equation to look something like this: have nth root of something equal to some number. Here we remember to check if n is even and the number on the right side is negative. We have to remember to conclude that there are no solutions to such equation, because even radicals are always positive. Now, if that's not the case, then we raise both sides of the equation to the power n. And then we solve the equivalent equation. Whatever that equation is. So let's get started. First, I'm going to isolate a radical term. I'm going to pick any radical, and I choose to isolate the square root of 2x plus 3. So I'm going to subtract the square root of x minus 2 from both sides. Next, I'm going to square both sides of the equation. And since I'm not sure about the sign of the right-hand side, I'm going to remind myself later to check for extraneous solutions. Now, when squaring both sides, we're using these two properties. The square of any positive number is the number itself, and the square of the sum and the difference can be found by using this formula. So the left-hand side of the equation therefore becomes 2x plus 3, and the right side becomes 16 minus 2 times 4 times square root of x minus 2 plus square root of x minus 2 squared. So let's compute all the numerical expressions and simplify this, and there we go, we have a new equation. So to solve this equation, we have to first figure out its type, and the type of this equation is also radical, so we have to repeat steps 1 through 3 again. So step 1 is to isolate a radical term. In this case, we only have one radical, so we're going to bring it to the left hand side, and then we're going to collect everything else on the right side. So we're going to subtract 3 and subtract 2x from both sides. Once we have a radical expression isolated, now we can square both sides. And here we're going to use this property. If you have a number and a radical raised to a power, then we have to remember that that power will be applied to each part of the product. So the left-hand side squared will give us 64 times x minus 2, and the right-hand side squared will give us 11 squared minus 2 times 11x plus x squared. So let's distribute everything and combine all the terms on one side. So I'm going to collect all the terms on the right side. So I'm going to add 128 to both sides. We're going to subtract 64 from both sides. And this is a quadratic equation. So to solve this quadratic equation, let's write it in standard form. And now we have three choices. We can either complete the square, we can factor it, or we can use quadratic formula. So give yourself 5 seconds to factor it. So if you don't see how to factor it, then use quadratic formula. So there's an error here. It should be 86x. So the factorization is x minus 83 and x minus 3. So the answer is 3 or 83. However, we have to check for extraneous solution. So let's check x equals 3. So when we plug in 3 into the equation, what do we have? Square root of 2 times 3 plus 3 plus square root of 3 minus 2 equals 4. Is that true? Square root of 9 is 3, square root of 1 is 1, so that is true. Let's check x equals 83. Square root of 2 times 83 plus 3 plus square root of 83 minus 2. Is that equal to 4? Let's find out. Square root of 81 is 9, and square root of 169 is 13. So 13 plus 9 is not equal to 4, so that's not true. That means the solution set of this equation has only one value. It is 3, and 83 is considered to be an extraneous solution. So this is how we solve a radical equation with two radicals.